Hi everyone, Harsh this side. Hope you all are having a great time ahead. So friends, in today's lecture, we'll study about Huffman encoding, right? We'll figure out how do we calculate the number of bits for each character in Huffman code, how to plot and draw the Huffman tree, right? The graph of the Huffman tree, the diagram of it, and we'll also learn about the mechanism and the algorithm of Huffman encoding, right? So get yourself comfortable on a sofa, serve yourself a cup of coffee and popcorn as well, and let's get ready to start. So guys, to start with, let's suppose that you have been given this sequence of characters and you have been asked to draw and plot the Huffman tree for these sequence of characters and also to calculate the number of bits in the Huffman coding for each of these characters. So our first step is that we create a table consisting of two columns, character and frequency, and we try out to calculate the frequency of each of the unique characters that are present in this sequence. So we have A, B, C, D and E, right? Now just calculate the frequencies of each character. A appears 1, 2, 3, 4 times, right? B appears 1, 2, 3, 4, 5, 6, 7 times. C appears 1, 2, 3, 3 times. D appears 1, 2, just 2 times, and E appears 1, 2, 3, 4 times. So guys, the next step is, as you all can see, I have arranged the characters and written them in increasing order of their frequencies, right? So from the table we calculated that the frequency of D was 2, so it is kept at the first position, and B was having the maximum frequency of 7, so it is kept at the last position, right? Increasing order. Now what we'll do is, from this sequence, select the two characters having the least frequency, the most minimum frequency. So D and C are those characters definitely. So we pick D and we pick C, right? For D, the frequency is 2. For C, the frequency is 3. Now what we'll do, introduce an edge here, introduce an edge here, make a node here, and what value this node will contain? The value of this node will be equal to the sum of the frequencies of its child nodes. So the value here will be 5, because 5 will be the sum of the frequency of D, that is 2, and the frequency of C, that is 3, right? So we have got a node here which is 5. Now what we'll do in this sequence, we will cancel out D, we will cancel out C, and instead of D and C we will write out their resultant, right, which was 5. So we'll write 5 E A B. Now E was having a frequency 4, A was having 4, B was having 7, as we can see from the original sequence. So now what do we have to do is, this sequence that we have obtained, we have to rearrange this sequence again in increasing order as we did in the first step, right? So we'll write E, then A, then 5, then B. E was having a frequency of 4, A was having a frequency of 4, B was having a frequency of 7, and the frequency of 5 comes in between 4 and 7. Alright. Now we repeat the same procedure. From this sequence, we select two nodes or characters having the least frequency. So E and A are having the least frequency respectively of 4 and 4. So this is the node of E, this is the node of A. Frequencies are 4 and 4. We introduce two edges and also create a new node whose value is the sum of frequencies of E and A, which is 8, because 8 equals 4 plus 4. Alright. And what we'll do now, since we have actually done our calculations using E and A and created a new node, so now we'll cancel E and A from this list, and instead of E and A we'll write the resultant, that is 8, in this list. And we will, now we have three numbers 8, 5 and B. We will sort them in increasing order once again. So the increasing order becomes 5, then B, because B is having a frequency of 7, and finally the number 8. Alright. So guys, continuing with the same trend, what we'll do from this sequence, we'll pick the two characters having the least frequency. So 5 and B, that is 7, are having the least frequency. So take 5, take 7, right? And 7 is B. Introduce two edges, introduce a new node, and the number inside this node has to be the sum of the frequencies of 5 and B, that is 5 plus 7, it's 12, right? Because 12 is equal to 5 plus 7. Now since we have done our calculations using 5 and 7, so cancel out 5 and 7 from the list, and instead of them write their resultant, that is 12. So now 8 and 12 become the new list. Now what we'll do, arrange these numbers 8 and 12 again in increasing order as we are doing since the start, right? So 8 and 12, so this is our new list. Now again we'll follow the same pattern. What we'll do, 8, this is one node, 12, this is another node, introduce two edges, create a final node, and the number has to be the sum of 8 and 12, so it is 20, because 20 is equal to 8 plus 12. Now since we have done our calculations using 8 and 12, cancel out 8 and 12 from the list and write 20 here. Now you will see that there is the 20 is the only number which is left in the sequence, right? Now since only one number is left in the sequence, it means that we are done, and the only number left in the sequence is the root of the final Huffman tree. All right. So now as you all can see, we have four structures A, B, C and D since we started the video, right? Now since just now we discussed that 20 will be the root node, right? Because 20 was the element which was remaining at the last of the sequence. It was the only element which remained till the last. So now we are going to draw the final Huffman tree. So to draw the final Huffman tree, first we'll write the root node. The root node is 20. Now what is 20 connected to? What are the left and right children? We can see from this structure, D. So 8 and 12 are the children of 20. So write 8 and write 12. Right? Now we can see from structure C that even the node containing the value 12, it has two further children, 5 and 7. So branch 12 further. 12 will be branched into left and right child, 5 and 7. Right? Now we can see this node A, 8, it also has two further children, a left child, a right child, and what are the values? We can see from this structure B. 8 is having 4 and 4, right? And one last thing, this 5 can also be branched further into left and right child, as we can see, as is evident from the structure A, and it can be branched into 2 and 3. Alright, now the thing to note here is, this is one level, all these are at one level, these four nodes are at one level, and these two nodes are at same level. Alright, now what we do in Huffman, this is the final Huffman tree. Alright, now what we do, we assign 0 to all the left sides or the left children of the tree, and we assign 1 to all the right sides or right children of the tree. So as you can see, this is an edge that is slanting towards left, so we'll assign 0 here. Then we'll assign 0 here also, because this is an edge slanting towards left. We'll assign 0 here from 12 to 5, because 5 is the left child of 12, and we'll assign 0 here because 2 is the left child of 5, right? And now what we'll do, this is an edge which is slanting towards right, so we'll assign 1 here. Similarly, we'll assign 1 at this edge because 7 is the right child of 12. We'll assign 1 here because 3 is the right child of 5, and we'll assign 1 here because 4 is the right child of 8. Alright. So now as we all can see from these substructures, now have a look here. This value 2. This was the node D initially, right? So assign the name D to this value, to this node D, 2, right? This 3, the name was C, so assign C to this third node. This was E, right? 4, so this is E. This 4 was A, so assign the name A to this 4. And this 7 was B, So this 7 is B, right? Now one thing to note friends here is, take this subtree for example. There were two nodes, two children 8 and 12. So what is the smaller child? 8, because 8 is less than 12. Hence the smaller child will always come on the left side, right? Since 8 was smaller than 12, so 8 has to be the left child of the parent node, and 12, it was greater than 8, hence the greater node will be the right child of the parent node. Similarly, in this C substructure, 5 was less than 7, hence 5 will come on the left side of the parent node 12, and 7 will come on the right side of the parent node 12. Alright. Now as everyone can see, we have finished drawing our final Huffman tree. Our tree is completely ready. Now some points to note here. You know these characters E, A, D, C and B. So the characters always appear at the leaf nodes in a Huffman tree. What are the leaf nodes? The nodes which do not have a further child. They are known as leaf nodes. So as you can see, E, that is this 4. This doesn't have a further child towards left or right. And similarly this D, C, B, they don't have further children, right? So the characters always appear at leaf nodes in a final Huffman tree, right? Now this was the table that we made in the start. The characters and the frequency we calculated initially. Now we have to find the Huffman code of each of the characters A, B, C, D, E through this tree, right? Now how to calculate it? Now see, this is node A, right? So you have to calculate the Huffman code of A. Now to calculate the Huffman code for any character, what we do, start from the root node, right? Traverse the root node till we reach that particular character in the tree, and whatever combination of zeros and ones you get, just merge them and write them together in order to get the Huffman code for that particular character. For example, A. Where is A in the Huffman tree? See, here. A is here, this one. So what we'll do, we'll start from the root node, that is 20, and we'll make a path till A. So this is from 20 we go to 8, then we go to 4 to finally reach A. So what are the combinations of zeros and ones that we encountered? First we came across a 0, then we came across a 1. So the Huffman code for A is 0, 1. Understood? Similarly the process for B. This is the node B. So from 20 we come straight down here following this path towards B, right? From the root node till that particular node which we want to arrive at. So what are the combinations zeros and ones? This is a 1, this is a 1. So 1, 1. This is the Huffman code for B. Alright. Now following similar trends for remaining characters. Now this is C, this node. So how to come to C? So from 20 follow this path, then follow this path, then from 5 we reach till 3, right? So what are the combinations of zeros and ones that we encounter? We first come across a 1 from 20 to 12, then we come across a 0 from 12 to 5, and then we finally come across a 1 from 5 to 3. So we write 1, 0, 1 as the Huffman code of C. Now we have to calculate the Huffman code for D. So first locate where is D node, this, right? Now how can we reach D node? From the root node, which part do we have to take? So from 20 we'll go to 12, then from 12 we'll go to 5, and from 5 we'll go to D, right? So what are the combinations of zeros and ones? So we come across a 1, a 0 and a 0, right? The Huffman code of D becomes 1, 0, 0. Now finally, what's the Huffman code for E? So this is E, and you can land directly at E from the root node following this path, right? So you get 2 zeros as you traverse through this path. So the Huffman code for E is 0 and 0. Alright, so we have calculated the Huffman codes for each character. Now note one thing. Out of all these characters A, B, C, D and E, B was having the maximum frequency, right? 7. And how many bits are there in the Huffman code for B? There are just 2 bits, right? And which character was having the least frequency? D. It was having the least frequency 2. And how many characters are there in the Huffman code for D? There are 3 bits in the Huffman code for D. So the thing to note is the number of bits in the Huffman coding of any character is inversely proportional to the frequency of that character. Alright, you have to remember this, it's very important. The number of bits in Huffman code of any character is inversely proportional to the frequency of that character. So thank you everyone. This was everything about today's session. Hope you enjoyed the video and understood the core concepts of Huffman coding, how to build a tree and how to calculate the number of bits in Huffman code of any character. Please like the video, share it and subscribe to the channel, and we'll meet very soon. Take care.